Okay, P3-30 has this interesting slot that why they would do 16 millimeters off the tangent point, um, and in line with the 7 millimeter hole. It just doesn't really make any sense. So we're given that geometry, and so this falls into the category of we design for convenience and we detail for manufacturing. So when we go into the drawing, we're not going to do it this way. We're going to find some um, dimensions that make more sense and detail this to where a machinist would not be having to calculate out those numbers. All right, so shape is relatively simple, but we are going to have to work with that geometry. So let's go into our metric part and top plane. Open up the sketch, go into our circle, and we have a diameter of 58. So I can go right into the smart dimension and apply the diameter, and the height is 60. And we want to turn off the offset from surface, put in the 60, and that's good. All right, so one of the reasons that we would want to attach the circles and geometry to the origin is this now is bisected by the right and the front plane. Depending on which way we want to orient it, we want to um, make it look like the picture. We'll go to the front plane, and I'll open up a sketch. We're putting in the geometry, and I want to avoid that midpoint, so we'll move up above it, and then we can go to the top edge, and even though that's a radius curved surface projected into the plane, it's a line. Okay, so we can go to the angle, set our 30 degrees, and I'm just going to leave that open. From the center back is 12 millimeters, so we'll go to the origin, and I'll drag straight down until I get a horizontal dimension and put in the 12. All right, leaving this open limits us to extrude cut, and we're going to go through all both directions. So if I just accept through all, it shows me the preview. Sometimes it will only do half. All right, but it in this case turned on the through all both. If I go back and check, direction 1 is through all, direction 2 is through all, so it creates it. If for some reason it only did half, we would edit it, go back into the feature, and activate direction 2 in the same way. All right, so to make this work a little easier, we can generate the geometry. I don't want to make this too complicated. I don't have, well, we'll do that as an after optional type geometry. What I need to start to make this easy is a sketch that goes from the quadrant up 16 millimeters. Okay, so that is at the tangency point. That's it. That's all I need for that sketch. When I go back into the bottom plane, I'm going to look for that sketch wherever it ended up, and I'm going to draw my rectangle. So this goes, I'm just doing a right click and select. This can go to, it doesn't matter. I'll go to the midpoint, and this can go coincident, and we set a width of 16. And then when we make the cut, we're going to extrude cut through all and generate the geometry. So it's 16 this way, but when we actually get to our geometry, I'm getting 12.73. Yeah, I've gotten a couple of different answers today, so that does not surprise me. All right, so Let's take another track at this, and I'm going to do a what if scenario and see if I can use the cut extrude vector. So I want to suppress my current cut extrude. I'm going to edit sketch 3 and make that a construction geometry. We can generate our rectangle, same basic process of setting it as a midpoint, setting it coincident, and then setting the distance to also be 16. Right, and then we have this view that we can turn on temporary axes. So that gives us a line where through any radius, any diameter, any cylinder or cone, those types of geometries. What I need that for then is to extrude cut, and we're going to do through all, but notice that it goes in the direction normal to the angled face. When I switch to the construction geometry, it's still through all, it's finding and it's keeping the angle, which looks kind of strange to me, but it does terminate and it generates that same shape. When I'm done, I can turn off the temporary axis. We had 12.73. Oh, that's what I did is when I was looking at this before, I was picking out to the tangency point. All right, so too many numbers, too many strange things going on here. 12.73, even in and of itself, is kind of a strange number for a 16 millimeter. Yeah, I guess a 16 millimeter pin to go through there. Yeah, it's offsetting it pretty far into the geometry. So we'll have to take a look at that in the drawing. So let's go. I switched into my S mode. So since I hit the S key, and if I pre-select, I have the whole wizard on the S key. I'm going to stay with what I've been doing though. So we're going to go up to the command manager, select the whole wizard. We have a regular hole. The advantage here is if I just drew that and extruded, I have a flat bottom. And then I have to make a note in the drawing that it can be drilled, or no, it has to be say a 7 millimeter end mill to make it flat bottom, or some combination for the geometry. So the whole wizard is going to give me a drill point that references that geometry a little bit better. So let's keep scrolling until we get to 7. No, I'm going to say sometimes it'll let you type that in. We want to go blind to 20 millimeters deep. And then the position, since I pre-selected, it goes to the face. Again, if you see 3D sketch or anything else, just come over and select the face. Get into that face, and then the next thing that you select will be the point. All right, so from the edge is going to be 9 millimeters. Again, that edge is not really something that's inspectable or to reference. So from the center or from the edge would be better. A select on the point, control select the origin, and since I moved the mouse, I lost the pop-up, and we'll go ahead and make that horizontal from the property manager. All right, we can go ahead and select that, and that gives us a shape. So there's a couple ways to approach this. And it's not always easy, but this should follow the standard of making a keyway. Again, if it's something that comes down to what's going on in the assembly, let's go ahead and mark this face with some kind of appearance that says we probably want to look a little further into that. Why is it that way? That we can go back and pick up that geometry. All right, so P3-30 and put some initials, and we'll save it. All right, so next we'll be going into the drawing packet.